Alrighty, so let's move on to meta-regressions. Okay, so we've slightly covered the difference between subgroups and meta-regressions. Meta-regressions are going to do two things. They're going to formally test whether there's a difference between groups. They're going to do three things. They're going to formally test whether there's a difference between subgroups. They can use continuous moderators. And the other thing they will do is use a tau squared, a shared tau squared, right? So it's going to use all the information we know about variance, okay? So let's start with a meta-regression on a continuous moderator, right? So we said you simply can't do a subgroups analysis with a continuous moderator. One of the moderators we have here is percentage female, right? So this is what percentage of the sample were female. So we might want to know, does that percentage relate to the effect size? All right, so let's run a meta-regression to check that. So we're going to, let's overwrite our res object, RMA. So same syntax as before, yi bi data equals dart. And we're just adding in an extra parameter here called mods. And put this tilde sign here, that this is basically showing you it's the right side of the equation, right? So if you think of this as an equation, you're predicting the effect size, which is the left side of the equation. The right side of the equation is percentage female. This is slightly weird syntax. All right, and we can have a look at that. All right, so we see compared to the first meta-analysis we now have this percentage female line here. Okay, and so what this is telling us here is the effect of an additional percentage point of females. All right, and you can see for every extra female, you lose 0.0017 effect size. So your correlation coefficient goes down by 0.0017. So not much at all. But the p-value 0.13. All right. So this isn't significant. We can do the same thing. All right, so this is a continuous variable, all right? And we can say here, when we're writing up this paper, we can say there was no significant moderation of the effect size by a percentage. So studies that had more females didn't tend to find bigger or larger effect sizes. Let's do it with a categorical variable. So exact same syntax for a categorical variable. If we go back to our data file, one of the other moderators we have here is sample. Okay. High school community, workplace samples. All right. So same thing. yi vi data equals dot mod equals sample. Okay, and you can see here we have these extra rows here, high school and workplace. All right, so why do we have two rows here? It's because we have three groups. So if you think about a regression, a normal regression you would run in stats, if you have three groups, that means you have two dummy coded predictors in the model. And so here we're comparing a community sample to high school. This is this first line here. So this is the difference between high school and community samples, all right? And you can see it's not significant. This line here is the difference between community samples and workplace samples, all right? And what it's saying is that you get larger effect sizes rather in workplace samples than you do in community samples, okay? Now, you can interpret that, I'll put some notes down below here. This intercept can be interpreted as the average correlation coefficients for studies using the community sample, right? Because that's our reference category. Okay. This next effect here is the estimated difference in the average corrected correlation between studies using a high school sample compared to the community sample, right? So you add 0.06 to this to get your, so it's about 0.1 for high school, all right? And this last estimate here is the difference between community sample and workplace. So this is, if you add this to this 0.04, that will be your kind of estimate for the workplace sample. One easy way to test this, all right, and it's effectively doing giving you the effect size, is we can rewrite this code just with this -1 here, all right? So if we just put a -1 after the sample and rerun it, what it does is it runs it without the intercept. And you can see here, all right, 0.1, all right, which is 0.06 plus 0.04, 0.2 plus 0.04 is 0.24. All right, so it's just, these are our three estimates of the effect size for each of these three groups. Okay, how is this different to a subgroups? What if we had just done this as a subgroups analysis? Well, the difference is that we've used a shared estimate of heterogeneity. And so we have a sample size of 51. We haven't had to kick out any of our sample, and we managed to estimate the effect sizes for each of these groups, okay? So, you know, and we could do the exact same thing with branch. Okay, and you can see here, rather than running subgroups analysis, we've run this as a meta regression with the intercept removed, and we can see these are our effect sizes for each of our branches and total EI. And you can see the only one that's actually significant is emotion management.